Jupiter's moon Europa is slightly smaller than Earth's moon. Its surface is smooth and bright, consisting of water ice crisscrossed by long, linear fractures. Like our planet, Europa is thought to have an iron core, a rocky mantle and an ocean of salty water beneath its ice crust. Unlike Earth, however, this ocean would be deep enough to extend from the moon's surface to the top of its rocky mantle. Being far from the sun, the ocean's surface would be globally frozen over. While evidence for this internal ocean is quite strong, its presence awaits confirmation by a future mission. Europa orbits Jupiter every 3.5 days and is locked by gravity to Jupiter such that the same hemisphere of the moon always faces the planet. Because Europa's orbit is slightly stretched out from circular, or elliptical, its distance from Jupiter varies, creating tides that stretch and relax its surface. The tides occur because Jupiter's gravity is just slightly stronger on the near side of the moon than on the far side, and the magnitude of this difference changes as Europa orbits. Flexing from the tides supplies energy to the moon's icy shell, creating the linear fractures across its surface. If Europa's ocean exists, the tides might also create volcanic or hydrothermal activity on the seafloor, supplying nutrients that could make the ocean suitable for living things. Based on the small number of craters observed, the surface of this moon appears to be no more than 40 to 90 million years old, which is quite youthful in geologic terms. Along Europa's many fractures, and in splotchy patterns across its surface, is a reddish-brown material whose composition is not known, but may hold clues to the moon's potential as a habitable world. NASA's Galileo mission, which explored the Jupiter system from 1995 to 2003, made numerous flybys of Europa. It obtained the closest images to date of the moon's fractured surface, revealing strange pits and domes that suggested the ice could be slowly turning over, or convecting, due to heat from below. Also of particular interest were regions of chaos terrain, which contain broken, blocky landscapes covered in the mysterious reddish material. Scientists think that chaos regions represent places where geologic activity has disrupted the otherwise smooth surface. In 2011, scientists studying Galileo mission data announced the intriguing idea that chaos terrains are places where the surface has collapsed above lens-shaped lakes perched within the ice. In 2013, NASA announced startling evidence from researchers using the Hubble Space Telescope that Europa might be actively venting plumes of water into space. The finding generated considerable excitement among scientists, as it provided evidence that the moon is geologically active in the present day. If confirmed by follow-up observations, the plumes could be investigated by future missions in similar fashion to the Cassini spacecraft's flights through plumes of Enceladus. Europa is special among the bodies of our solar system in having a potentially enormous volume of liquid water, along with geologic activity that could promote the exchange of chemicals from the surface with the watery environment beneath the ice. Indeed, it could be the most promising place in the solar system to search for signs of present-day life. Evidence for an ocean. One of the most important measurements made by the Galileo mission showed how Jupiter's magnetic field was disrupted in the space around Europa. This measurement strongly implied that a special type of magnetic field is being created, induced, within Europa by a deep layer of some electrically conductive fluid beneath the surface. Based on Europa's icy composition, scientists think the most likely material to create this magnetic signature is a global ocean of salty water. Future missions to Europa will likely seek to confirm the presence of its ocean. For example, measurements of the amount of flexing due to the tides are one important indicator. If the ocean exists, the tides should deform the surface by about 30 meters, 100 feet. If the moon is frozen through, the tides should stretch the surface by only 1 meter, 3 feet. Also of great interest will be the composition of the reddish material on the surface. Scientists would like to know if this material holds clues to the composition of the ocean and whether material is cycling between the surface and the interior. Discovery. Europa was discovered on January 8, 1610 by Galileo Galilei. The discovery, along with 3 other Jovian moons, was the first time a moon was discovered orbiting a planet other than Earth. The discovery of the 4 Galilean satellites strengthened the view that planets in our solar system orbit the Sun, instead of Earth. Galileo apparently had observed Europa on January 7, 1610, but had been unable to differentiate it from Io until the next night. How Europa got its name. Galileo originally called Jupiter's moons the Medicean planets, after the Medici family, and referred to the individual moons numerically as 1, 2, 3, and 4. Galileo's naming system would be used for a couple of centuries. The names Io, Europa, Ganymede, and Callisto were officially adopted after it became apparent that naming moons by number would be very confusing as new additional moons were being discovered. Europa was originally designated Jupiter II by Galileo because it was the second satellite of Jupiter. Europa is named for the daughter of Agenor, in ancient Greek mythology. Europa was abducted by Zeus, the Greek equivalent of the Roman god Jupiter, who had taken the shape of a spotless white bull. Europa was so delighted by the gentle beast that she decked it with flowers and rode upon its back. Seizing his opportunity, Zeus rode away with her into the ocean to the island of Crete, where he transformed back into his true shape. Europa bore Zeus many children, including Minos. Enceladus is Saturn's sixth largest moon, only 157 miles, 252 kilometers, in mean radius, but it's one of the most scientifically compelling bodies in our solar system. Hydrothermal vents spew water vapor and ice particles from an underground ocean beneath the icy crust of Enceladus. This plume of material includes organic compounds, volatile gases, carbon dioxide, carbon monoxide, salts and silica. With its global ocean, unique chemistry and internal heat, Enceladus has become a promising lead in our search for worlds where life could exist. Geology. In 2005, Cassini's multiple instruments discovered that this icy outpost is gushing water vapor geysers out to a distance of 3 times the radius of Enceladus. The icy water particles are roughly 1/10,000th of an inch, or about the width of a human hair. The particles and gas escape the surface at jet speed at approximately 800 miles per hour, 400 meters per second. The eruptions appear to be continuous, refreshing the surface and generating an enormous halo of fine ice dust around Enceladus, which supplies material to one of Saturn's rings, the E-ring. Several gases, including water vapor, carbon dioxide, methane, perhaps a little ammonia, and either carbon monoxide or nitrogen gas make up the gaseous envelope of the plume. Interior. In 2015, researchers analyzing years of data from Cassini found the magnitude of the Moon's very slight wobble as it orbits Saturn can only be accounted for if its outer ice shell is not frozen solid to its interior, meaning a global ocean must be present. The finding implies the plumes are being fed by this vast liquid water reservoir. The measurements suggested a large sea about 6 miles, 10 kilometers, deep beneath the southern polar region, under an ice shell about 19 to 25 miles, 30 to 40 kilometers, thick. Surface. Enceladus is one of the brightest objects in our solar system. Covered in water ice and reflects sunlight like freshly fallen snow, Enceladus reflects almost 100% of the sunlight that strikes it. Because Enceladus reflects so much sunlight, the surface temperature is extremely cold, about -201 degrees Celsius, -330 degrees Fahrenheit. About as wide as Arizona, Enceladus displays at least 5 different types of terrain. Parts of Enceladus shows craters up to 22 miles, 35 kilometers, in diameter. Other areas show regions with no craters, indicating major resurfacing events in the geologically recent past. There are fissures, plains, corrugated terrain, and geysers that are likely all related to the liquid interior of the Moon, even though it should have frozen eons ago. It is possible Enceladus is heated by a tidal mechanism similar to Jupiter's moon Io. The south polar region of Enceladus is almost entirely free of impact craters. The area is littered with house-sized ice boulders and surfaces carved by tectonic patterns unique to this region of the Moon. A huge cloud of water vapor over the area and relatively warm fractures in the crust supply the cloud of water vapor and ice particles that extend into space. Scientists came to informally call the deep crevasses tiger stripes. The jets originate near the hottest spots on the tiger stripe fractures, also known as sulci. Orbit. Enceladus is one of the major inner moons of Saturn along with Dione, Tethys, and Mimas. It orbits Saturn at a distance of 148,000 miles, 238,000 kilometers, falling between the orbits of Mimas and Tethys. It is tidally locked with Saturn, keeping the same face toward the planet. It completes one orbit every 32.9 hours within the densest part of Saturn's E-ring, the outermost of its major rings, and is its main source. Enceladus is, like many moons in the extensive systems of the giant planets, trapped in an orbital resonance. Its resonance with Dione excites its orbital eccentricity, which is damped by tidal forces, tidally heating its interior, and possibly driving the geological activity. Potential for life. With its global ocean, unique chemistry and internal heat, Enceladus has become a promising lead in our search for worlds where life could exist. Exploration. Discovered in 1789 by William Herschel, little was known about Enceladus until the two Voyager spacecraft passed nearby in the early 1980s. Then in 2005, the Cassini spacecraft started multiple close flybys of Enceladus, revealing its surface and environment in greater detail. In particular, Cassini discovered water-rich plumes vending from the South Polar region. Discovery. British astronomer William Herschel spotted Enceladus orbiting Saturn on August 28, 1789. How Enceladus got its name. Enceladus is named after the giant Enceladus of Greek mythology. The name Enceladus, like the names of each of the first 7 moons of Saturn to be discovered, was suggested by William Herschel's son John Herschel in his 1847 publication Results of Astronomical Observations Made at the Cape of Good Hope. He chose these names because Saturn, known in Greek mythology as Cronus, was the leader of the Titans,